Hello, and Dr. Harris here, wanting to work some additional problems from the material, the worksheet that I handed out in class over exponential and logarithmic functions. In particular, in these first three examples, we're wanting to solve equations. And so these first two examples come under the heading of number 2 on the handout. If two expressions are equal, then their logarithms are equal. And so here in this first equation, I've got e to the 4x plus 1 equals 15. So if these two expressions, if the left side is equal to the right side, then any logarithm of the left side will be equal to that same base logarithm on the right. In general, we're going to use the natural logarithm for this process. And so the first step I would do is I would say that the natural logarithm of e to the 4x plus 1 is equal to the natural logarithm of 15. And now we get to use our logarithm properties that the natural logarithm of e to some power is just that power. So remember that the logarithm of an expression, the natural logarithm of an expression, is the exponent you would put on e in order to get that expression. And so to get e to the 4x plus 1, I would put an exponent of 4x plus 1 on this. So the natural logarithm of e to the 4x plus 1 is 4x plus 1. And so that's equal to the natural logarithm of 15. And then I can solve for x by subtracting 1 and then dividing by 4. And so if I ask for an exact answer, which I am pretty likely to do on quizzes and exams, this would be what I would be looking for: 1/4 the natural logarithm of 15 minus 1. If I put that into a calculator, I might also ask, what is that value to, say, 3 decimal places? Then you could punch this into your calculator and you would get that to 3 decimal places, this is 0.927. So again, if two expressions are equal, at least one of them involving an exponential expression, then we want to say that their logarithms are equal. Same idea occurs here in the second example, 10e to the 2t minus 14 equals 17. But we have a couple of extra steps that we need to do before we can apply logarithms. So in order to use the logarithm property of natural log of e to something is that something, we need to get that exponential expression by itself. And so I need to add 14 first. When I add 14 to 17, I get 31. And then I want to divide by 10. And 31 divided by 10 is 3.1. Now, at this stage, I can apply logarithms. And so natural log of e to the 2t is just 2t. So 2t is natural log of 3.1. And t, the exact answer, would be 1/2 of the natural logarithm of 3.1. But again, if I want to know what this is in decimal form approximately to 3 decimal places, this is going to be 0.566. So if two expressions are equal, their logarithms are equal. That's a good tool to have. The third type of equation that we've got is if two expressions are equal, then we can use them as exponents with equal bases. And so this is how we're going to solve problems that have logarithms in them. And so if the logarithm of an expression is equal to a number, then we can use both the left side and the right side as exponents with a particular base. With a natural logarithm, the base that we want to use is e, of course. And so if these two things are equal, then e to the left is equal to e to the right. And again, a natural logarithm is the exponent I would put on e to get what's inside. So if I raise e to that power, I'm going to get what's inside. So I get 4x minus 5 equals e cubed. And from here, it's pretty straightforward to solve for x. And so I would get x equals 1/4 e cubed plus 5. That's the exact answer. A decimal approximation to 3 decimal places is 6.271. So that's what I have on that from the handout. These are the examples I would have worked on for the handout if we'd had enough time in class. There's one other problem I told you I wanted to work, though, and that's thinking about inverse functions. And so suppose I wanted to find the inverse function of f of x equals e to the 3x plus 2. What is f inverse? We know that exponential functions are one-to-one, so they have inverses. And so we use our strategy of writing it at first as an equation involving y and x. We switch the role of x and y, and then we solve for y. To solve for y, we're going to apply our property, or what we talked about in strategy 2. If two expressions are equal, then their logarithms are equal. So natural logarithm of x is equal to the natural logarithm of e to the 3y plus 2. Again, the natural logarithm of e to the 3y plus 2 is just 3y plus 2. And so I can turn this around and say that 3y plus 2 is natural log of x. Then it's easy to solve for y. Y is 1/3 of the quantity natural log of x minus 2, and so that is my expression for f inverse. F inverse is 1/3 of the quantity natural log of x minus 2. So I hope these examples are helpful in terms of approaching your homework. Please reach out to me if there's something I can do to help.